Distributed file system. Most computing is done on a single processor with its main memory, cache, and local disk. Local disk is otherwise known as a compute node. In the past, applications for parallel processing uses special purpose parallel computers with many processors and specialized hardware. Also, in large-scale web services, thousands of independent compute nodes are used. In these cases, the compute nodes uses commodity hardware, which reduces the cost compared with the special purpose parallel machine. That is, in web services, thousands of compute nodes or local disk will be operating independently. But in parallel processing, they are using special purpose parallel computers. These computing facility give rise to another generation of programming language. So it uses the advantage of parallel processing and it avoids the reliability problems that arise when the computing hardware is used. Actually, the computing hardware, what do you mean by reliability? Means the computing hardware are operating independently, and if any of one fail, then the whole system will fail. Physical organization of computing nodes. So, the new parallel computing architecture is known as clustered computing. What is the advantage of this architecture? It uses the benefits of parallel computing and it avoids the reliability problems due to independent compute nodes. Okay, this gives rise to cluster computing. So these compute nodes means local disks, are stored on a rack. Usually 8 to 64 compute nodes are stored in a rack and it uses a gigabit Ethernet. There may be many racks of compute nodes and rack may be connected by another level of network or a switch. The bandwidth of inter-rack must be greater than the intra-rack Ethernet. The figure shows the organization of compute nodes. Here, these are the rack. This one is the rack, and in each rack, 8 to 64 compute nodes are stored. Here, 8 to 64 compute nodes are stored, and these racks are interconnected with a switch. Distributed file system. Most computing is done on a single processor with its main memory, cache, and local disk. Local disk is otherwise known as a compute node. In the past, applications for parallel processing uses special purpose parallel computers with many processors and specialized hardware. Also, in large-scale web services, thousands of independent compute nodes are used. In these cases, the compute nodes uses commodity hardware, which reduces the cost compared with the special purpose parallel machine. That is, in web services, thousands of compute nodes or local disk will be operating independently. But in parallel processing, they are using special purpose parallel computers. These computing facility give rise to another generation of programming language. So it uses the advantage of parallel processing and it avoids the reliability problems that arise when the computing hardware is used. Actually, the computing hardware, what do you mean by reliability? Means the computing hardware are operating independently, and if any of one fail, then the whole system will fail. Physical organization of computing nodes. So, the new parallel computing architecture is known as clustered computing. What is the advantage of this architecture? It uses the benefits of parallel computing and it avoids the reliability problems due to independent compute nodes. Okay, this gives rise to cluster computing. So these compute nodes means local disks, are stored on a rack. Usually 8 to 64 compute nodes are stored in a rack and it uses a gigabit bit Ethernet. There may be many racks of compute nodes and rack may be connected by another level of network or a switch. The bandwidth of inter-rack must be greater than the intra-rack Ethernet. The organization of compute nodes. Here, these are the rack. This one is the rack, and in each rack, 8 to 64 compute nodes are stored. Here, 8 to 64 compute nodes are stored, and these racks are interconnected with a switch. Okay, the components may fail. Components include compute nodes and interconnection node. The components failure includes loss of a single node or loss of the entire rack or its interconnection networks. Some calculation may take minutes or even hours on these thousands of compute nodes. So suppose one component is failed during computation. Then we need to restart the whole system and the process may be repeated like that. The solution to this problem includes file must be stored redundantly or computation must be divided into tasks and one task is assigned to one component. such that if one of the machine fails, then the other computation will goes on. We just need to restart the failed node. To exploit cluster computing, we use a new file system known as Distributed File System or DFS. A large number of files can be stored in distributed file system. So the size may be terabytes in size. It is to be noted that if you are using files rarely, then don't use DFS. Rather, read some data and compute it, and additional data is appended to the files if needed. For example, an airline reservation system is not suitable for DFS because in this scenario, data is changed frequently. Files are usually divided into chunks, usually 64 megabytes in size. Chunks may be replicated 3 times at 3 different compute nodes. However, the nodes holding the copies should be located on different racks, so we can avoid the reliability problem. That is, if one of the racks fails, then we won't lose the whole data. Normally, the chunk size and degree of replication can be decided by user. In order to find the chunks of a file, you can use another file called master node or name node. Again, in order to avoid the loss of data, this master node itself can be replicated and the directory for the whole file system knows where to find its copies. Again, the directories may be replicated so that all participants know where the directory copies are. So, first files are divided into chunks. Chunks may be replicated, and replicated it is stored at compute node, and again compute node can be stored in different racks. So the details of chunks are stored in a file known as master node or name node. Again, master node can be replicated, and these are stored in a file directory where to find its copies. The directory itself can be replicated, and all the participants using DFS knows where the directory copies are. DFS implementation include Google File System, Hadoop Distributed File System, which is an open source DFS used with Hadoop. Hadoop is an implementation of MapReduce, and it is distributed by Apache Software Foundation. Then another open source DFS is called CloudStor. It was originally developed by Cosmix. MapReduce is an internal implementation of Google. This implemented in several systems. In large-scale computation, MapReduce implementation is used to manage the compute nodes in such a way that it is tolerant of hardware failures. It uses two functions, map and reduce. It manages the parallel execution, coordinate the task, execute, map or reduce, and it will keep track of all the failure of the above task. Actually, MapReduce is implemented using two functions, map and reduce. It is used for parallel processing. Okay, computation steps. Map tasks are given one or more chunks. Where these chunks come from? Chunks are from distributed file system. So from the distributed file system, you will get chunks. And chunks are assigned to map tasks. Then these map task will turn the chunk into a sequence of key value pair. So this will issue key value pair. Actually, this key value pair is determined by the code written by the user. So depending upon the scenario, it will vary. Then the key value pairs from each map task are collected by a master controller and sorted by key. So this one is collected by a map controller based on key and it is sorted. Then this map controller divides these keys to each and every reduce task. So all key value pairs with the same key will wind up at the same reduce task. So first of all, from the DFS you will get the chunks and the chunks are given to map task and map task will generate key values and these values are sorted out used by map controller and map controller passes these key value pairs and keys are divided among reduce tasks. Okay, reduce task work on one key at a time and combination of all such values associated with that key in some way and these combinations are determined by the user code. Okay, schematic diagram of MapReduce computation. So here we will be using a DFS. From the DFS you will get some input chunks. These are input chunks. So it is fed to map task and map task will generate key value pair and key value pairs are grouped by controllers who it is group map controller will sort all the keys and it is passed to reducer. Each task is given to the reducer and all after doing the computation by the reduced task all the results are combined and this combination is done by user code. Input to a math task consisting of elements may be tuple or a document. A chunk is a collection of elements and no element is stored across two chunks. Actually, the input and output of all map tasks and reduce tasks are of the key value pair form. But the input to the map task, it is the key of input elements, are not relevant.